The method I'm going to explain to you today. So we are using 4 different methods to determine if this project is acceptable or not. Okay, so if you um, have a project, for example, so we have capital budgeting project. We have 2 projects as these 2 samples, project A and B. So we can see we have 2 projects. The project A, when they talk about the time 0, that means your initial investment is 0. And time project, you invest 10,000 US dollars. Okay, that's negative. It goes out of your pocket money. In the first year, you will get revenue 3,500, and the same for next 3 years until year 4. And for project B, you will invest the same amount, which is 10,000 US dollars. But the first year you got $500. Second year you got 500. The third year you got 4,600. And the fourth year you got 10,000. So that's all your revenue you will get from invest in that. Okay, invest in that project. Okay, let's say we have this 2 projects. Let's go and I open that Excel spreadsheet. Open that Excel spreadsheet. You have 2 projects. Okay. 2 Excel projects. Okay, 2 projects. Let me see. Okay, so we have 2 projects, and we type in the time. And this is a project A. This is project B. So you have 2 projects. Okay, time 0. Assume that the life of each project is 4 years. Initial investment, you invest 10,000. Okay, remember in Excel when you put a parenthesis, like 10,000, okay, that's a negative. Okay, that will be negative. So the same thing. Okay, because why this is negative? Because this is your investment, so the money goes out of your pocket, and you will receive 3,500 for the first year, and then the same for next 3 years. And for project B, and your initial investment is 10,000 US dollars. You receive 500, 4,600, and 10,000. Okay, that give you the cash flow of those 2 projects. And so we're gonna go over each method and to show you how to make a decision. And for what is the payback period for project A? And for project A, so what we do is okay, so for project A, we do the payback period. So is payback period for project A. Okay. So you just take the revenue from your initial investment. So you can see the first year, right? The first year. So you got 33,500, but your initial investment is 10,000. So that's gonna give you this amount. Okay. That's the money you still need to get it back. So you end up with, you lose still 6,500 after the first year. And then the second year, at the end of the second year, so you have this. And then you get 3,500. You get 3,500. Okay. So after the second year, you see you already need $3,000. In the third year, you can see, okay, this is your money left. And during the third year, you get 3,500. So you see the sign already changed. So you already, at the end of the third year, you earn 5,000 already. So your payback period, so what is your payback period? Your payback period is going to be, you see that you lose 3,000 during that year, right? It's 3,000, but the whole year you got 3,500. So it's going to be that 3,000 divided by the 3,500, and your time plus 2 years. So that's give you around like a 2.85 year. So you got your money back. Okay, that's your payback period. And for the payback period of project B, okay, you can see at the first year, okay, so you only got $500 back, right? And the second year, you got another $500 back. And the third year, okay, you got 4,600, but you still lose money, 4,400. So it's still negative. So at the end of the first year, so you can see that number become positive. So you end up with 5,600. If you do that calculation, you will see this is going to be this amount, right? So 44,000 left. That year you earned with 10,000. Okay, and then you plus this 3 years. So that's your payback period. So the payback period, you choose which one. Okay, that's the question. Because this takes longer for project B. Okay, so the payback period, you want the shorter, the better. Yeah, it takes some longer for you get all your money back for project B. So this is your choice. Okay, let's say we choose okay, project A, because this is shorter the payback period. Okay, so let's say, you know, this is how you can get to the calculation. The payback period for project A, 2.9 years. For project B is 3.4 years. So project B takes longer time. So actually, if you just do the calculation, you will accept the project A. Okay, so the payback period looks, very straightforward. However, there is a question. The question is that you just want your money back. Okay. In reality, so if you have that $10,000, you might invest in the bank and you can get interest, or you invest in some other project. They can bring you some returns and profit. You just it not just only the money you want your money back. Okay, that's the one thing. Another thing, is that you got that $10,000 back in 2 or 3 years later, 3 or 4 years later. So that $10,000 is worth less than that $10,000 you invest today. So that's we talk about the time value of money before. Okay, the $100 today worth more than the $100 in the future, right? So you cannot compare that. So basically there is several drawbacks of the payback period. So that's why we introduced the concept is called net present value. So the net present value is going to measure the real value of the future cash flow. Okay, you take that discount of that future cash flow and you compare that to the present. Okay, you compare it to the present. So for example, you have this project, and what is the net present value? So net present value, you have to do discount. You get discount like the project B, right? Project B, you discount that. If you know the interest rate is 10%. Okay, so let's say we do this, we put the interest rate. Okay, the interest rate is 10%. Okay, so what will be the net present value of that project B? Net present value of project B. Okay, this is the present. Okay, we don't have to calculate. Okay, for that 500, you can see that 500. Okay, discount for one-time period divided by 1 plus that. This is a 1 plus, okay, 1 plus that 10%. So we want the dollar sign to lock that 10%. We don't want this one to change. And raised to the power of the time period. Okay. Okay. So that you can see the 500, if you compare that 500 year later, actually the present value is 454, right? This is the 454 or 455, you discount for one-time period, the present value is less than that 500. Okay, for another 500, so we can do the same formula. Okay, apply the same formula, we can see that this is your net present value. That 500, if 2 years later, is worth even less. Okay, it's $413. That 4,600, 3 years later, is the same amount, equivalent to $3,456 at present. So you can see that that's how we do the present value. Okay, $10,000 in the future, discount for 4-time period is worth 6,830 at present. So So what is the present value? Okay, you sum them up. Okay, you sum them up. Okay, there's a okay, all the future cash flow equivalent or to 11,154. Okay, that's the present value. And because you have 1,000 or 10,000 initial investment, so your net present value will be this number. Okay, exclude your present value. So your net present value actually is 1,154. Okay, and so we can do the net present value use the way we did, like this, to discount and sum them up minus your initial investment. But we have another way, it's very handy in the Excel spreadsheet, is called net present value function. Okay, the net present value function is going to be, we type NPV function, the NPV function, select the rate, 10%, and you select all these values. And plus your initial investment. Okay, that's your net present value. Okay, so they give you okay percent. So we need to format this. Format the cell to number week 2 decimals. Okay. Project A. Okay, the net present value is $1,094.85. And for project B, we can calculate the net present value is equal to net present value 10% rate. And you have this, the future cash flows or the positive cash flow, and you add the initial investment, which is a negative. Okay, so you can see it's close to this one we calculate, right? So actually, you're using different decimals as exactly the same. Okay, so we can calculate net present value use net present value function for both project A and B. So what that means, okay, when you get the numbers, okay, so this is we're gonna make a decision. We calculate net present value. Okay. If the net present value, okay, except the project if the net present value is greater than 0, okay, greater than or equal to 0. So you will accept the project if the net present value is greater than 0. Okay. If the projects are independent, accept both project. Okay, as long as this net present value is positive, you accept the project. If the project are mutually exclusive, so what do you mean mutually exclusive? You can accept only one project. That means you accept one, you have to reject another one. Okay, if 2 projects are mutually exclusive, accept a project with a higher net present value. Okay, so you have both projects acceptable if they are independent. If you have to choose one, or the 2 projects are mutually exclusive, so which one you're supposed to choose? You choose the project with a higher net present value. So which one is higher? Project B, right? Project B, they have a higher net present value. So we're gonna choose is this one, okay? So both projects are acceptable if they are mutually exclusive. So we choose project B. Okay, now we talk about the other one. So we talk about internal rate of return. So now we do what is internal rate of return. So the internal rate of return method, we're gonna determine which project I'm going to choose. Okay, look at this internal rate of return. So internal rate of return is equal to, okay, you can do the IRR function. You just select all the values. Project A, you select all the values. Okay, select all the values. It'll give you, click on enter, so you will get internal rate of return, 15%. So we can get more decimals. Okay, internal rate of return is 14.96%. And this is going to be internal rate of return. The internal rate of return will give you for project B. Okay, is 13.5%. So which project, which one you're gonna accept, or okay, this is the decision. If you have internal rate of return, okay. So if the internal rate of return is greater than the required rate of return, you accept the project. Okay, so we can see for both project, the required rate of return is 10%. So you accept both project if they are independent. Okay, if you have to choose one, all these two projects are mutually exclusive. Okay, you accept the project if the internal rate of return is higher, okay, is greater. So you compare these two, you see the internal rate of return for project A is higher. So you wanted to do, you choose the higher internal rate of return. Okay, if they are mutually exclusive, and you choose project A. If they are independent, so both projects are acceptable because the internal rate of return, all these numbers is greater than this 10%. Okay, all of them are greater than 10%. Okay, so when you have the internal rate of return, so what does that mean, the internal rate of return? The internal rate of return will give you the net present value equal to 0. Okay, so that means at, okay, so with conclusion here, at the internal rate of return, the net present value will be 0. Okay. Okay, for example, we have, okay, this project A, right? Project A. So we wanted to see how this net present value changes. If this net present value is 14.96%, so we change this one to 14.96. We change it to 14.96%. Okay, for example, this one, internal rate of return. Okay, so we can see the net present value is almost 0, right? Almost 0. So it's closer to 0. So we add more decimals. Okay, 14.963. It's going to be 0. Or you just type this one equal to the internal rate of return. See, net present value equal to 0. So what is the modified internal rate of return? So modified internal rate of return is MIRR. So the modified internal rate of return is modified internal rate of return is the discount rate that causes the project's present value of the outflow to equal the project's terminal value of the inflow. So that's the definition for modified internal rate of return. So modified internal rate of return avoids the problem of multiple internal rate of return. So internal rate of return, sometimes you could get 2 or more solutions, okay? So the modified internal rate of return, you can type an IRR function in Excel. So you can choose the rate. Here this is your, all the value. You select all the values. And you do the finance rate, 10%. This is reinvest rate. So you select that. And you're going to modify the internal rate of return. Add more decimals. Okay, you select all the values of project B. The finance rate and reinvestment rate. Okay, so modified internal rate of return, you can see both of them are greater than 10%. So both of them are acceptable. And this one is higher if the 2 projects are mutually exclusive. So you're gonna choose the one with a higher internal rate of return. Okay, so you might have curious, okay, different method, what you use is going to be make a different decision, okay? So it depends on what type of method you use. And okay, so we do this to show you how to use different methods to make the capital budgeting decision. And so let's see, what about the 2 projects, you know, you have net present value and the internal rate of return, make you different decisions. So which project you're gonna choose. Okay, so for example, we have this, you know, is that when you're using net present value, you choose project B, right? You project B. And when you use the internal rate of return, you choose project A. So they give you different, right? So now we have, I want to show you is if these 2, the internal rate of return and net present value give you different suggestion or they are conflict. So what we should do is we can do the net present value of project A and B. So we create the rate series we call net present value profile. So you have 2%, and then you have a series of different rates. Let's say we have this, you know, like a series of return, the interest rate, and then we do the net present value of project A, and we have a net present value project B. The net present value Okay, it's a net present value function. We have use the rate, and we select the rate, all these values. Okay, and so we have all the values in close parentheses, and we plus initial investment. So we put $sign. Okay, that's a net present value for project A. Okay, so we have this one. Okay, we make this to using numbers. Keep 2 decimals. Okay, so we have the net present value for project A, and the same we do net present value. Okay, net present value function. We choose the rate and all these values. Create carefully, and we plus the initial investment. Okay, so that's gonna be the net present value profile for project B. So you click on enter, apply the same formula. Okay, so now we can see we got a net present value profile. So based on different the rate, what is the net present value gonna be? So we have this one. We make a graph. So this is net present value for project A. Okay, and then the rate is going to be on the x-axis. And then we add project B right here. So right click, select data. So we add project B. Data. Okay. So we have a net present value for project B. Okay, so we have project A and B. So they have a cross point somewhere here. We wanted to know what is the cross point. Right click, select data. So you add it, the rate. Okay. Okay. So we can see around like a 10%. Around the 10%, that means they have a crossover point. Okay. And so which project you're supposed to choose if they are conflict. So we need to have our net present value profile. That means if you see this is project B, this is the B, the orange one. Okay. If the required rate return is less than 10%. Okay, because this is you see project B has a higher net present value than project A at any given rate. Okay, so you choose a project A. If the required rate of return, if the required rate of return is greater than 10%. Okay, for example, you can see this is greater than 10%. Okay, the rate. This is the crossover point. So you will choose the blue line. Okay, this is the project A. At any given point of the interest rate, project A has a higher net present value. So you're gonna, if that is the case, you choose project A, B. No. If this is lower than 10%, you choose B. Okay. Yeah, this is the orange one. Yeah, this is the B. Okay. If this is greater than 10%, you choose A. Okay, when you have the two projects and the results are conflict when you're using net present value or either internal rate of return, give you different solution. So you will have to do the map present value and to determine which one you choose to find the crossover point. That's how they do, find a crossover point. Okay, so I think that's all for today. Do you have any questions?
No questions for me.
Okay, good. So yeah, if you still have any question, send send your question to my email, so I will be glad to help.
Okay, so for Form 2 part, that is a test that's covering chapters 4. I mean, that's covering the portion that we're going over, right? Correct?
Yeah.
Okay, so Form 2 assignment, because I've already did the assignment portion 4, but the Form 2 is a quiz or a test to speak, right?
Mm-hmm. Yeah.
Okay, I just wanted to make sure that I was correct because I seen it had multiple choice and fill in and true or false, I believe.
Okay. Yeah.
Okay.
Mm-hmm. Okay.